Okay, welcome back, class. And today we're going to start section 2 on statistics. So in section 2, we're going to talk about measures of central tendency. So those are like the center of a data set. And we're going to find what are the different measures of central tendency and how to calculate them. So we're going to learn how to determine what the mean, or what we call the arithmetic average, or just average of a data set. So we use the word mean, but it means the same thing as average. So we're going to determine the mean of a data set. We're going to learn how to calculate or determine what the median of a data set is and what the difference between those two are. 3, determine the mode of a data set and determine the mode. Um, oh, there's something else here. Not the mode. Is it the mid-range? The mid-range. I don't know if that's correct or not. What is that? Well, we'll get to that, but I believe that's the mid-range. This is a typo. Okay. Okay, so the mean. We all know what the mean is. It's the average. So all you do, since grade school, we've been doing this, you add the numbers up and you divide by the total, the number of observations there are. So if you have 5 numbers and you want to find the average of those 5 numbers, you add the numbers up and you divide by 5. If you have 7 numbers, you add those numbers up and you divide by 7, and so on and so forth. So that's what this formula means. So the mean of a data set is you add up this. This is the symbol sigma, capital sigma. It's a Greek letter, and we use this to represent summation. It represents the sum of all x values. So if we have a set of values, then each value is our x value, is an x value. And so we sum up all of those x values and divide by the sample size. N is the sample size. It's the number of observations in the sample. So that is the formula for the mean. So in this one, in calculating the mean, we say, are investors born or made? It would be nice to think we could all be great inventors, but history shows otherwise, or says otherwise. Based on a sample of adults in 10 selected countries, shows wide agreement that inventiveness is a quality that can be learned. Find the mean percentage of adults in the 10 countries who agree that inventiveness can be learned. Okay, so here's the tables. Okay, so we've got this side-by-side table. So the blue represents the percentage of people who believe that inventiveness can be learned, and this is the group of people that believe it is inherited. Okay, and so we want to find the average of those people who believe that inventiveness can be learned. And so we're going to find the average of these 10 percentages. Okay, and so we take those 10 percentages. Each percentage is an x value. We're going to sum up those x values, those percentages, and divide by 10. So we add up all of those values and divide by 10, and we get 79.9. So the average percentage of people who say that inventiveness can be learned is 79.9%. So that is a measurement of center, or a central tendency. Now, what if we have grouped data, okay, or values that occur more than once in a frequency distribution? Well, then we can use a different formula that will give us the same answer. Now, the mean, or what we call the sample mean, is x bar. Okay, so the symbol for the mean is x bar. So we can use the sum of x divided by n. But what if we have repeated values? Well, then what we can do is we can take all of the values, right? So we can still use the summation of x divided by n. But if we have repeated values, well, we could just multiply that value by how many times it shows up. We're going to get the same answer, but this one brings in frequencies. Okay, so we could either add up all of the values, and so if we have in a data set 6 2's, then we can add 2 plus 2 plus 2 plus 2 plus 2 plus 2, or we could just take the product of 6 times 2 and we'll get the same thing. Okay, so the only difference is we're bringing in frequencies for repeated values. So it's the sum of all of the products of x times f, and then we divide by n. Okay, so x bar represents the sample mean, x represents the value, frequency represents how many times that value occurs in the data set, and so we're going to take all of those products, sum them up, and then divide by the sample size. Okay, and so in this case here, where we've got 0 that shows up 2 times, so we can do 0 plus 0, so we could do 1, and then we could do plus 2 plus 2 plus 2, and then we could add 3 12 times, right? And so we can do this the long way, or we could just multiply each value by its frequency and get the same answer using the new formula, this one. Okay, so if we use the formula, we're going to first multiply across, right? We're going to multiply the value of x times its frequency, so we'll have another column for the products. Then we're going to add up all of those products and then divide by the total sample size, which is the sum of all of these frequencies. Okay, so now this table to the right shows the students' responses to questions, how stressed have you felt the last 2.5 weeks? On a scale from 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible. Use the frequency distribution to find the average or the mean level of stress of the stress ratings, the average or mean stress level ratings. Okay, so what we're going to do is we're going to apply our formula. So here's our column. So we're going to multiply across these columns here. And so here's the column of products. So all we're doing is multiplying across, and we get all of these values. And then what we're going to do is the summation says we're going to sum all of these values. So we're going to sum down this column. And so that's going to give us 975, right? That's the sum here. And so that gives us our numerator. And then we're going to sum all of these values because n is actually the sum of the frequencies. So you could actually, the more general form of this formula is instead of using n, and n is always good, but we can say n is also equal to, and I've seen this formula written this way in other textbooks, but n is actually the summation of the frequencies. Okay, but again, just remember that that's the sample size. So if you add up all of the frequencies, you get the sample size. So it's n. Okay, so again, don't worry about, just remember that to get n, you're just summing up all the frequencies. Okay, so now the median. Now the median is the data that's in the smack middle of the data set. Okay, so it's where 50% of the data is below it and 50% of the data falls above it. That is the median. Okay, so it's different than the mean. Now, the median is the middle of the data set when you rank or order the data. Okay, so you have to order the data. To find the median, you have to order the data first. So that's step number 1. You arrange the data items in order. Okay, and it doesn't matter whether you do it smallest to largest. It really doesn't. You can do largest to smallest or smallest to large. That doesn't matter. But it has to be in order. It has to be arranged. 2, if the number of data items is odd, then there is a middle. Then there will be a middle number. So the middle number will be your median. If your data set has an even number of values, then there will be no quote-unquote middle number. Okay, so to find the median, you'll have to take the 2 middle data items and take the average of those 2, and that will be your median. It's that easy. Okay, that's how you find the median. So if we have this data set here, okay, the first thing we're going to do is we need to order the data from least to greatest. So here it is. We have the least. Now all you have to do is by inspection, you just look at it. And so we know that this is an odd number, so the median is right here. So the middle number is 90. So the median is 90. That easy. That's it. Now what about this one? Well, it's a larger data set. So again, the first step is we're going to have to order it. Okay, so we order it from least to greatest, and we figure out where the middle is. So we basically count to the middle. So we look at the middle, right? So what we do is we start pairing up. So visually, what I do, and what you can do too, is this. You start pairing up the outside ones. So 7 goes with 74, 13 pairs with 68, 15 pairs with 59. And you can do this faster with your eyes than I'm doing with here, obviously. And as you move in, you pair up. And in this case here, because you have an even number, everything pairs up, and so you don't have a middle number. So what do? You take the two middle numbers, and you take the average or the mean of those two middle numbers. And so in this case, the median is 31. And then that's it. Okay, now finding the median with a formula. So you can do it by inspection, but what if you have a large data set? Okay, you're not going to want to try to figure it out by inspection. Okay, so there's a very easy formula that you can use. Now, and it depends on whether you have an odd data set, an odd number of data values, or an even number of data values. Okay, so again, the thing is you have to have it ordered. Okay, so in this case here, we have 9 numbers. Okay, so it's ordered from least to greatest, but there are 9 numbers here. So it's an odd number of values, which means that there's a middle. So if you want to find the middle number, the formula is n plus 1 divided by 2. Now this tells you the position of where you will find the median. It will not give you the median number, but it will tell you how many spots to count to get to the median position. So in this case here, you have 9 values, so it's going to be 9 plus 1 divided by 2. So 10 divided by 2 is 5. So that means you have to count 5 spots, and you'll get to the median on the 5th position. And it does not matter where you start, which end you start with. So if I start over here, okay, so if I start here, 1, 2, 3, 4, 5, the median is 28. Or if I start over here, 1, 2, 3, 4, 5, I still reach the median. The median is 28. Now, what if it's an even number? Okay, if it's an even number, then the formula is just n divided by 2, and that will give you the position of where to find the first number. And then you just take the second number with it and average them. Okay, so now let's take our data set here. So how many values, how many numbers are there in this data set? So in other words, what's the sample size? In this case, the sample size is 151, which is odd. So we know that there is a median. There's a middle in the data set. So the median is in the data set. So how do we find it? Well, in this case, I'm not going to want to count all the way to the middle, but I can use the formula. So the formula says since it's an odd number, I'm going to add 1 and divide by 2. So I add 1, divide by 2, and I get 76. So the 76th position. So I need to count until the frequency adds to 76. Okay, so this is going to be 3, 6, 18, and then what do you get? 18 gives you 34, right? 34, 44, 52, 62, 65, and then 76 crosses right in here. So that tells me what's the median. The median score is going to be what? 7. Okay, so we count down the frequency until we find the 76th data option. And so that's what we did right here. So the 76th position happens right in this right here. So 7 is the median stress level. Now, What happens with why do we have two different measurements of center? It really depends on the data set. Well, which one should we use, right? I mean, that's a great question. Is it better to use the median or the mean? It depends on the data, okay? So here we have 5 employees in a manufacturing plant earning salaries of the following, okay? So these are the following salaries, okay? Now the section manager has an annual salary of $95,000. Now let's find the median salary, annual salary for these 6 people. So again, if we find the median, we arrange them in increasing order, and we find the median. Well, what's the median in this case? Well, in this case, it's an even number. So if we take n, which is 6, divided by 2, that's 3. So we count 1, 2, 3. This is the first one. And then we're going to take the second one and we're going to average these two. We're going to take the mean of these two. And so we find that the median is $22,050 per year. Okay, so that's the median. Okay, so far so good? Okay, now, what about the average, the mean? Well, that means we're going to add up all of the salaries and divide by 6. We find that the average salary is $33,700. A big difference, right? The median was $22,050. The average was more than what? $11,000 more. Over $11,000 more. Well, why is there such a big difference between the mean and the median? Well, the reason is because we have this one salary here that is really big. Compared to all of these, this one is much, much bigger. And so the mean is sensitive to large values in a data set. If we have a couple large values, then the mean is going to be more affected by the large values, the extreme values. So they could be extremely small or extremely large compared to the bulk of the data. Okay, we call this skewed data. Okay, if we have a data set that has some really large values compared to the rest of the data, or some really small values, those might be what we call extreme values or even outliers. And so the mean is very sensitive to those. It's affected greatly by extreme values or outliers, or what we call skewed data. Okay, the median, on the other hand, is not sensitive, is not very sensitive to extreme values at all. In fact, we could change this number to 1,000,000, and the median is still going to be the same. It will not be affected. Okay, so it is not as affected. It's still affected, but it's affected not as much. Okay, not nearly as much as the average. Okay, and so if we have skewed data, or if we have data that has extreme values in it, it's better to use the median rather than the mean. Now, if everything is good and there's no extreme values and everything is pretty much in a nice like group, and there's no like values that are far from the pack, then we would use the mean if we had a choice. The mean and the median will both be the same in that case, or very, very close to each other. But in that case, we use the mean because the mean is easier to understand, and many people have an intuitive understanding of the mean. Okay, so for example, we don't talk about average family income because family income is skewed, because there's a few people out there that have large family incomes, but majority of people have incomes that are much smaller than that. And so when we talk about median income, family income, in the United States or anywhere else, we tend to use the median. The median is a better choice when we have those types of situations. Okay. Now the mode. Now the mode is extremely easy to understand. It's the value that occurs the most often in a data set. The mode that has the highest frequency, okay, than the other values. Now, The mode is not unique, which means the mode, you could have one mode, you could have many modes, or you could have no modes. Okay, it's not like the median or the mean where you only have one. Okay, the mode, you could have none, you could have one, or you could have more than one. So in this data set, what is the mode? Well, in this case, the mode would be 7 because it occurs twice where all the other values occur once. Now, the last one is the mid-range, and that's the one that I thought they were going to talk about. The mid-range is a crude and not very accurate measurement, but it is a quick and easy measurement if you're just wanting something to get a quick idea of the middle. And it's called the mid-range. And basically, you basically find the midpoint of the lowest and highest value. So you take the lowest and highest value and you take the average of the minimum and the maximum. That's the mid-range. This is not a very good, accurate measurement because it's based on the highest value and the lowest value. And what if one of those two or both of those values are extreme values or maybe even an outlier? Well, then that's going to cause a huge effect on the mid-range. So the mid-range is not a very accurate, trustworthy value. But hey, if you're looking for something quick and easy to get a general idea, to get a quick idea of what the middle is, the mid-range is your guy. It's not something I would always hang my hat on, but it's something to start with. Okay, so in this case here, we're going to have a Newsweek magazine examines factors that affect women's lives, including justice, health, education, economics, and politics. Using these 5 factors, the magazine graded each of 165 countries on a scale from 0 to 100, the 12 best places to be a woman and the 12 worst places to be a woman are shown on the next slide. Okay, so find the mid-range among the 12 best countries to be a woman. Okay, so now the 12 best places to be a woman are right over here. Okay, so what's the mid-range? Well, the mid-range is we take the lowest value and the smallest value and we average them. So in this case here, 87.2, that should not be a dollar sign, by the way, 87.2 and 100. So we take the average of these two, and this is the mid-range. So the mid-range is 93.6. And that's the end of this, And this is the end of this section. So again, make sure you practice these, do the suggested homework. If you get stuck in any of the online homework or anything else, please ask questions. Email me, ask questions in class. Bring your those problems. Let me know what those problems are, and we'll tackle them in class together. Again, please practice, and we'll work on it together in class. And other than that, have a great day, and I'll see you later. Bye-bye.